Hi everyone, good evening to all. Welcome back to Pathway. I know I took a long break in between. I was busy with my personal schedules and I had joined for fellowship now. So now just I was exploring some new ways of teaching. So I saw this notes app. So let's see, we'll be discussing today about basic IHC patterns. I am new to this app. So just sorry if there is any mistakes that I'll be doing. Okay, so if you imagine this is a cell, before that we'll get to the basics of the IHC. So in IHC, first of all, if this is the tissue, okay, and this is the antigen, you know that antigen antibody reaction is the one which is basic for identifying IHC. What is IHC? Is immunohistochemistry. We are identifying a tumor or a cell by the proteins inside it. Okay, so the protein is the antigen, so we will be using antigen antibody reaction. So this is the protein if we want to detect, so we will be giving a primary antibody against it. Okay, primary antibody against it, and against that you will be giving another secondary antibody. Okay, now the secondary antibody is against the primary antibody. We get an antibody against an antibody? Obviously, antibodies are also proteins, same as the antigens. So you, in any bodily protein against which we can get an antibody. So since antibody itself is a protein, so you can get antibody against antibody also. So the secondary antibody is against the primary antibody, and which is already associated with an HRP protein, okay, horseradish protein, something like that. And you will be using the DAB reagent now. Okay, when you use the DAB reagent, because of the peroxidase chemical reaction, then a brown product is achieved which gives color to the IHC. Okay, so this is what is the basics of the IHC, which many of the people might be knowing. If you don't know also, this I just put for people who don't know about it. So if you imagine, okay, this is the cell, okay, and this is the nucleus. Now what are the basic IHC patterns that you get? First pattern is the nuclear pattern. Okay, so you know that we are putting antibodies against the protein. So what are the IHCs that will be positive in nuclear? Against the proteins that are already present in the nucleus. So what are the IHCs that give you a nuclear pattern of staining? Okay, so those are usually ERPR. Okay, estrogen and progesterone receptors, you know those receptors are situated in the nucleus. So that is why those receptors give you IHC pattern, that is nuclear staining only. So the cell will be, if you're doing counter staining and all, then you will get the cell in this color. Okay, so basically the IHC will be looking like this, that is only the nuclear part will be stained. So ERPR is there, and then Ki67. Why Ki67? Because as you know, Ki67 is a mitotic marker, and nucleus, the function of the nucleus and the cell is to divide the cell. So in cell division you require nucleus. So Ki67 is a protein that is staining the nucleus. In the same way, the MIB1 also is giving you nuclear staining, and then others are TTF1, CDX2, WT1. These are the proteins that are present in the nucleus. Okay, I'm not telling these are the proteins that are already present in the nucleus. So you know when ERPR and all are normally present in the nucleus, okay, in your breast tissue and all. So when do you use this IHC is to see the cell origin. Okay, so when you use it for breast malignancy, when there is extra expression of the estrogen receptors, that is when you use the IHC to identify this is coming from the breast tissue. Okay, this is a tumor which is expressing more of estrogen receptors. There are also tumors which do not express more of the estrogen receptors. In that you will get negative or very less IHC positivity. So these nuclear positivity or the IHC markers are used to identify the tumor, as well as you can identify it to use in you can use it to identify the normal tissue also, like which tissue is what we are seeing, or whether there is the normal tissue or not also, but mostly we use it for oncological purposes. Then other nuclear markers are P53 and P63. Now, how does P63, P53 and all come? Because if you remember the starting chapters in Robbins, in that you have seen a cyclin diagram, okay, cyclin and the cyclin dependent kinases. In that diagram, you can see many P14, 15, 16, etc. So, what are these P markers are associated with those cyclins, which are directly associated with the cell division. So, obviously, those should be under the nuclear markers. I am new to this notes thing, so I don't know much to use. However, I will try to use it in a basic way. So, we are done with the nuclear staining. Now, next is the where did the brown color go? Okay, so next is the cytoplasmic staining. So in the cytoplasmic staining thing, you will feel it is like this, and then the nucleus, you can see it will be like really darkly present, and then at times cell membrane might not be highlighted, but you will see obviously a nuclear pattern, a cytoplasmic pattern. Okay, in sheeting it might be difficult, but when cells are present nearby and all, then you can see it. Where did the color go? Okay, so if there is nucleus here, nucleus here, nucleus here, then you will see the cytoplasmic pattern. I was using this pen, sorry if it is irritating. So this is the cytoplasmic thing. Okay, so you will see the cytoplasmic IHC in this way. So this color also, cytoplasmic IHC. So what will be giving the cytoplasmic pattern? Obviously the cytoplasmic proteins, okay, that are present in the cytoplasm. So that are given by the most common intermediate filament that are present in the epithelial cells are the cytokeratin, which you usually use for epithelial origin like adenocarcinoma, squamous cell carcinoma, etc. And then desmin, which is present in the muscles. Then there is vimentin, which is a mesenchymal marker. It's a bit of non-specific marker, but still we use it in basic setups like low budget setups, like most of the Indian setups. We are improving though. Then there is actin, and then there is ACTH. Okay, so that is about the cytoplasmic markers. Everything is gone. Okay. Then how will we there are some cells which will be giving, okay, both the nuclear and cytoplasmic positivity. Now these proteins are present in both the compartments, like in nucleus as well as the cytoplasm. There are only very less proteins in that way, that is nucleus plus cytoplasm, and those are the S100 protein, P16. Okay, I said to before that P16 is something which is coming, P things are coming in the cyclin, so it should come in the nucleus, but this protein is present in both cytoplasm and the nucleus at times. And then there is calretinin. There are exceptions to many things, that is why these things are present in both sides. And then there is beta catenin, but beta catenin thing that you have to remember is, oh, so I wanted to highlight it, but it became some stupid thing. So in beta catenin, the thing which you have to remember is when there is nuclear and cytoplasmic positive, that is normal, okay. But in medulloblastoma tumors, when you use, okay, you have to get it as only nuclear positivity. Then only you will tell it is medulloblastoma is present, okay. So beta catenin, when we use in that conditions, when it is mutated, there should be only nuclear positivity, okay. So this we were discussing on nuclear and cytoplasmic. Then the next pattern which we will be discussing is cytoplasmic dot positivity, okay. Cytoplasmic dot positivity. This became a rod like thing, but just imagine this is dot positivity, okay. So you will be seeing the nucleus which is very well highlighted. Suppose if you are thinking this is dark blue, okay, okay, and then you will have this as light blue. You have to look in high power or to understand there is dot like positivity, okay. Suppose you are seeing these are the other cells, okay, and in those things also you have your nucleus, your nucleus here, and then you have the cytoplasm here, okay, and then you will be seeing this dot like positivity like this. It's like, yeah, so it's not like very dot like positivity. So I'll just make a cap. Cap also went. So you will be seeing the dot like positivity like this somewhere, like this somewhere. So this is how dot like positivity is. So you should be keeping in mind that when this tumor is there, okay, and if it is going to give you the markers dot like positivity, you have to look keenly for the marker. So what are the markers that can give you cytoplasmic dot like positivity, okay. Those are CD30, CD15, okay. And one good thing you have to remember is that these are perinuclear. Now when in which tumor those are present, that you can go and find. And then so these you can see their position are perinuclear. Then the next pattern that we will be discussing is cell nucleus. So we said about nuclear and cytoplasmic, nuclear plus cytoplasmic, cytoplasmic. Now dot like positivity. Now there is also something like cytoplasmic granular positivity, okay, like this. You will see granules, granules, granules. There will be so much of granules. It's going to be difficult to rub for me. So anyway, it is for the study purpose. So see, this will be the nucleus you will be getting, and then there you will be granular positivity in the cytoplasm. So what are the IHC markers that are going to give you cytoplasmic granular positivity? So the cytoplasmic granular positivity will be given by napsin A, HEPAR1. So these are present in vesicles, maybe that's why you are going to get a granular kind of positivity. And then there is amaker, which is used in prostate. Napsin A is used in lung tumors. HEPAR, obviously HEPAR. So it is used in hepatocellular carcinoma and hepatocytic origins. So these are cytoplasmic granular positivity. Then lastly we will come on to, oh my god, this is going to take so much of my time. I knew the granular one is going to be hard. Anyway, I have done it good. Then you will have the last one, that is the membranous positivity. Now this became maroon color. Anyways, okay, so membranous positivity, how you will see, this is not round as such. So here you will be seeing here membrane. While doing IHC, it will be seen very membranously, and then you will see the nucleus, that is here, nucleus here, nucleus here, nucleus here. Okay, so this is how you see the membranous positivity. So what are the tumors that give you membranous positivity? Okay, those are CD3, CD markers, mostly CD20. Why? Because those cluster of differentiation are the proteins that are present on the cell membrane. Okay, so that is why you get those CD markers in the membrane usually. And then CD3 is for T cell, CD2, B cell marker, and then HER2, which is used in breast tumors, and then there is EGFR, which is used in lung tumors, and then E-cadherin, which is also used in breast. So, and other tumors also. So, these are the overall tumors and IHC patterns that you will be seeing. Thank you for watching. Do like, share, and subscribe.